Welcome to this walkthrough of Kops.dev, your go-to solution for automating multi-cloud infrastructure. Whether you're provisioning, managing, or monitoring your infrastructure across different cloud platforms, Kops simplifies the entire process, offering seamless integration and enhanced observability. In this video, we will guide you through the key features and functionalities that makes Kops an essential tool for cloud-native environments. Let's dive in and see how Kops can help you streamline multi-cloud operations. Let's begin by creating a cloud account. For creating the cloud account, we can choose from GCP, AWS, or Azure. We need to give the credential and a name for creating the cloud account. For generating the credential, we can use the setup guide and go through it, enable the prerequisite APIs and all, and use this shell script to generate the credential. This shell script will create a service account, attach the required permissions, and generate the service account credential. After generating the cloud account credential, we can use it and attach them to the cloud account. After attaching them, we will need to select the region we want our infrastructure to be deployed in, and in just one click, Kops will create everything automatically. It will create a VPC which will serve as a network foundation for our services, ensuring that they operate securely and efficiently, an artifact registry to manage our container images, and a Kubernetes cluster. You can see in the logs here the resources it has created, starting from enabling the basic APIs required for GCP and creating a VPC, to creating an artifact registry, and then a Kubernetes cluster. In the Kubernetes cluster, we by default install few tools for the smooth operation and efficiency and monitoring. We install Prometheus for monitoring, Nginx ingress controller for traffic manager, cert manager for handling certificates, and a Fluentbit for forwarding the logs of the services. On the cloud account infrastructure page, we can see the details of the Kubernetes cluster that got created, like region, the Kubernetes service it's using, and the machine type, min nodes and max nodes. Machine types and min nodes and max nodes can also be edited to whatever value users like. From the permissions page, we can manage the permissions of the users by adding an email, giving them a role, and by clicking add, it will be automatically reflected at the cluster RBAC roles also. So user has access to the on Kops platform as well as on the cluster level. We can see the jobs here and the logs and the changes that has happened at the infrastructure level on the audit log page. From the cloud account settings page, we can delete the cloud account or update the service account credential we used to create the cloud account. After creating the cloud account, we can go to the application page to create the application. We can select the name of the application we wanted. Select the cloud account in which we want to add that application. I have created one AWS cloud account also. We will select the GCP one. Select the SQL instance if we required any SQL instance or not, or Redis instance. We can choose the Redis instance on cloud or deploy a Redis master in our own cluster also. For now, we will not choose anything. We can create a demo app. We can add one more application. Select the MySQL Redis instance on cloud and add it. After creating the application, we can go inside the application and create a service. For creating the service, we will need to give it a name, and we can also choose a host type. If user chooses a custom host type, they need to provide the host they want to use and add a record with the cluster IP given here. If they choose a default host, Kops will automatically provide a host and manage that host, and we can create it. For creating a service inside the application which has a SQL instance or a Redis instance, we can just give it a name. We can give the database we need to use, and if we want to connect it to Redis or not. Kops will automatically create the database, a user for that database, and attach that user to the service so that it's get connected. Same for the Redis, it will automatically set the port and its host to the service configs so that it gets connected to the Redis. After creating services, we can go inside the services and see the image deployed for that services and edit it. We can also edit the HTTP port, metrics port, resources allocated to it, the data store connections, environment variables, and all. Similarly, for the cron jobs also, we can create one. We can edit the cron job configs also, like the schedule time, concurrency policy, HTTP port, metrics port, and all. If we go to the data source page, we can see the connection between the databases, SQL instance, and Redis instance and the services. After creating the application with SQL instance and the Redis instance, we can go back to the cloud account, go to the infrastructure page, and here we can see the SQL instances and the Redis instances. We can go inside them and see the details of them, like the server, cloud resource, and the MySQL version. We can edit the machine type and the storage disk from the infrastructure page. Kops not only simplifies the infrastructure management but also provides robust observability features right within the platform, like service logs. You can access real-time logs for a services with the ability to view the logs for last 15 minutes and quickly identify and resolve issues. On the metrics page, you will find a comprehensive dashboard displaying key performance indicators such as CPU utilization, memory utilization, request count over time, and pod restarts, and more. The dashboard offers a 30-minute view of these metrics, helping you monitor your service's health and performance at a glance. To ensure the health and performance of your services, Kops come with several default alerts such as replicas falling short, pod restarts, zero replicas, HP utilization, and memory and CPU utilizations. These pre-configured alerts ensure that you are immediately informed of any critical issues, enabling you to take appropriate actions. In addition to the real-time monitoring, Kops also supports long-term observability to give you a complete view of your infrastructure over time, through which we can select a cloud account. We want to install observability tools. We can choose creating a new cluster for observability or use the existing cluster. We can use the existing cluster here. Kops will install observability tool in the cloud account selected for observability and install Loki for log storage, Mimir for metric storage, and Tempo for traces storage. It will also automatically set up Fluent Bit for log forwarding to Loki, integrates Prometheus with Mimir for metric storage, and configure tracing solution for complete visibility. The automation ensures that observability tools are seamlessly integrated. Kops also install Grafana and automatically creates the data source for the observability tools that got added, like Loki, Mimir, and Tempo. You can log into the Grafana using this Grafana ID provided on the UI and the password and this URL. In the data sources, you can see the data source for all the observability tools that got added, Loki, Mimir, and Tempo. With Kops, managing multi-cloud infrastructure has never been easier. From seamless setup to powerful observability tools to automated configurations, Kops equips you with everything you need to optimize your cloud-native environment. Thank you for joining this walkthrough. If you have any question or need further assistance, don't hesitate to reach out to us at info@kops.dev or schedule a free call with us.